Okay, this learning target is about photoelectron spectroscopy, which is PES. All this is, and it's no more complicated than this, all this is a graphical representation of the electron configuration. So instead of 1s2, 2s2, 2p6, etc., it'll have a graph of the energies required to remove electrons in each subshell. The energy required to move an electron is going to be more the closer it is to the nucleus. So think about gravity. The closer you are to a planet, stronger the gravity. So the closer the electrons are to the nucleus, the more energy it takes to remove them. So explain the relationship between the photoelectron spectrum of an atom or ion and the electron configuration and the interaction between the electrons in the nucleus. Okay, great. The energies of the electron can be measured experimentally with photoelectron spectroscopy. The position of each peak is relative to the energy required to remove an electron. I said that already. And the height of each peak is ideally proportional to the number of electrons in that subshell. So 1s2, 2s2, 2p6. The p's have 6 electrons and the s's have 2. So the p peak should be 3 times as tall as the s peaks. That's all that's saying. So here's what one looks like. So we have peak there, peak there. That peak's about triple. Peak there, peak there. Most of the time, you're going to have little marks here. On every AP one, I've seen them with the y-axis labeled. If you notice, the y-axis is reversed to the x-axis. I think this should say x-axis is reversed, excuse me. So the binding energy, the most binding energy is over here. It starts at 250 and then decreases down to 5. So that's what it's reversed. Usually you have 0 here, and then it increases as you go that way. Not this one, it's backwards. Not sure why. But anyway, this one, 250, this has the most binding energy. So this is the most difficult to remove. It takes the most amount of energy to remove this electron, which means it's closest to the nucleus, 1s2. So these are the 2 electrons that are closest to the nucleus, which makes sense that they have the highest binding energy. Okay, then we have 2s2. This is about 3 times as large, so this is 2p6. And then here's 3s2, and then this is 3p something. We have to kind of decide whether it's 3p3, 4, 5, or 6. So if this is 2 and this is 6, halfway is about there, which I'd say, oops, that'd be 4, right? That's 4. So this looks like about 3 to me. So I'd say this is about 3p3. Then we can look at our periodic table and add these up. We have 2, 4, 10, 12, 15. So I find element 15, and this is a PES of phosphorus. So you can use this to identify elements and talk about the different locations of the electrons and the electron configuration. And that's it.